Hello and welcome to my college algebra lesson on 1.6, which is solving other types of equations, and we are using the Coburn book. Today we're going to be looking at some of the exercises on page 137. So the first other type of equation that we want to talk about are polynomials that are not your typical quadratic polynomial. So the section is labeled polynomials of higher degree, so something other than a squared. And you still want to just use your zero product property and factor them. And so we're just going to jump into number 16 here. And so 16 is x to the fourth plus 64x equals 0. And if you can factor this, you can use your zero product property because it's equal to 0 and set all of your factors equal to 0. So if we look at this first, factoring, you should always look for greatest common factor. And this has one. It has an x. We're going to pull the x out front. And we end up with that. And because x is cubed, that puts a little question in my mind. That is this a sum of cubes? Because this is x that's being cubed. And so is 64 something else being cubed? And it is 4 that's being cubed. And so then if we remember, our sum of cubes is a plus b times a squared minus ab plus b squared. And what we did just a minute ago is we found a and b. And so we're going to leave the x out front. A plus b turns out to be x plus 4. And then a squared is going to be x squared minus 4x plus 16 equals 0. Alright, and so from here we're going to set each one of these factors to 0. So you get x equals 0, so never drop that off. X equals 0, x plus 4 equals 0, and x squared minus 4x plus 16 equals 0. And so x equals 0, already solved. X equals negative 4, really easy to solve. And this last one here, we're going to have to solve this trinomial. And so then we got to start thinking, well, how can I solve this trinomial? It's not going to factor. It doesn't use square root property. You could complete the square with it, or you could do a quadratic formula. I more intend to use quadratic formula, but tell you what, just for the sake of practicing completing the square, this would be a good one. So you might just jot yourself a little note, either complete the square or quadratic formula. One of those is going to be needed to solve this. So let's complete the square. Let's see where we get there. So our first step, move c to the other side. So we get x squared minus 4x equals a negative 16. And then we need to take half of b, which is going to be 2, square it, add it to both sides. So we're going to add 4 to both sides. Factor, this is x minus 2 squared equals negative 12. So notice we're going to have an imaginary answer here, which is fine. Square root both sides. So we get x minus 2 equals plus or minus 4i square root of 3. Okay, make sure you know where except I did not do that right, did I? How about 2i? Because it breaks up into 4 and 3, and the 4 would become a 2. All right, add 2. And so then we get 2 plus or minus 2i square root of 3. And so there's 4 answers, and I should have 4 answers. So we got 1, 2, and here's 2 over here for 3 and 4. So still under the heading of polynomials of higher degree, I would like to look at number 26. So 26 is x to the fourth minus 625 equals 0. And as much as this probably doesn't look like a difference of squares, I want to check to see if it is a difference of squares because it kind of has that form to it. So is this something squared and is this something squared? So first of all, this is x squared that's being squared. And then this other one is 25 that's being squared. So this is a difference of two numbers that are squared. So there's my a and b. And in case you've forgotten, let's just remind ourselves that a difference of squares factors into a plus b, a minus b. So what we just did was find our a and our b. So this factors into x squared plus 25 times x squared minus 25. Okay, and we need to factor some more because x squared minus 25 happens to be another difference of squares. So we get x squared plus 25, not a difference of squares, times x plus 5 times x minus 5. And so now that we're completely factored, we're going to go through and we're going to set everything equal to 0. Okay, and so again, we have two that are fairly easy to solve. Okay, and what you really just have to do is employ all of your resources here. And so this first one to solve, we're going to need to use the square root property because we have one term that's being squared. And so I'm going to move the 25 to the other side, and then we're going to need to notice that we're going to get an imaginary answer again, which is fine, and it's plus or minus 5i. And I was looking for 4 answers, and there's all 4 of my answers. Okay, we're going to look at one more example under the polynomials of higher degree, and that's going to be number 28. And 28 has 4 terms, and so we're going to look at x to the 6th minus 3x to the 4th minus 16x squared plus 48. Okay, and so nicely equals 0, and obviously if it doesn't equal 0, you're going to move everything to one side to make it equal 0. And if there's 4 terms and I'm looking at factoring it, we're going to use grouping. And so what do the first 2 have in common? They have an x to the 4th, which would leave an x squared minus 3. And then what do the second 2 have in common? And they have a negative 16. And we're going to pull out the negative because I want that middle sign to turn negative. So that would leave x squared minus 3. And then if we do our greatest common factor, greatest common factor again, the x squared minus 3 comes out front, leaving us with an x to the 4th minus 16. And then hopefully you see that that x to the 4th minus 16 is a difference of squares. That is x squared that's being squared, and then 4 that's being squared. So this is going to be x squared minus 3 times x squared minus 4 times x squared plus 4. And again, we have a difference of squares, and so x squared minus 3, this is my new difference of squares, x minus 2, x plus 2, x squared plus 4. So you need to factor completely until you can't factor anything anymore. And we're going to come through and we're going to set all of that equal to 0. Okay, and we have 2 again that solve pretty nicely. And the other 2, we're going to have to use our square root property. So we're going to move, in this case, the 3 to the other side, becomes positive. Square root both sides, we're going to get x equals plus or minus square root of 3. So there's those 2 answers. And this one, the 4 becomes negative, and square root both sides, and x equals plus or minus 2i. And I was looking for 6 answers to begin with, and so we have 2, 3, 4, 5, 6, all 6 answers. So moving on to the next type of equation, we want to look at rational equations. And remember, a rational equation, or rational anything, is going to be something that's written with a fraction. And so let's go ahead and glance over at number 36. And there's 2 types of rational equations you can have, and here's the first one. 4 over 2y minus 3 equals 7 over 3y minus 5. And this is just a fraction equals to a fraction. And when you have this situation, your best bet is to cross multiply. And so we're going to multiply diagonally, and that product is going to equal the product of the other diagonal. So if you write it out, it's going to be 4 times 3y minus 5 equals 7 times 2y minus 3. And then from here, in this case, it's a really simple linear equation. So we're going to distribute. And then we want to move our y's to the same side. And at the same time, if you feel comfortable with moving your constants to the other side, or you could do that in another step, 1 equals 2y, and we get y equals 1/2. And in the case of fractions, you cannot have a negative, you can't have a 0 in the denominator. And so you always want to check to see if I put in a positive 1/2 into the denominator, so if I put this in for y, does that give me a 0 total for the denominator in either case? And the answer is no. If it did, that's called an extraneous solution, and you just cross that one out. So in this case, though, 1/2 is fine. It works for an answer. Alright, so we're going to look at a different type of rational equation. We're going to look at number 38. So you can only cross multiply if it's one fraction equals one fraction. And lots of times it's not that simple. So here we have the difference of two fractions equals a fraction. And if you really want to spend the time and combine the two fractions on the left, you could still do cross multiplication. I find it easier. We are going to multiply the entire equation by the least common denominator. And so what that does is that is going to cancel your denominators, because what makes these equations a little tougher than most is the fact that they're fractions. And so if we can eliminate them being fractions, then that's going to become easier to us. So what I'm going to multiply by is actually 10x squared, because if I gave everything the same denominator, that is what the denominator of everything would be. Now, we are going to distribute that to everything, so that monomial gets taken to everything. I'm going to write this out now, but I would probably not write this out on every step once you're familiar with these. But this is going to be 10x squared times 3 over 5x. I'm just going to put the minus sign there. 10x squared times 1 over 2x equals 10x squared times 1 over x squared. And I don't really want to multiply these together. I want to reduce them first. So here the x's are that's going to cancel, and that's going to reduce to a 2, and you're going to get 6x minus, x will cancel, and that becomes a 5. 5x equals 10. And so you see then I get this pretty simple linear equation just from canceling my denominators. And so then very nicely we get x equals 10. So that's the way that I prefer to solve rational equations, is just instead of giving everything a common denominator, multiply by that least common denominator. So what happens if the denominators are a little more involved than the last example? And for that, let's look at exercise 44. And so it starts out with negative 18 over 6n squared minus n minus 1 plus 3n over 2n minus 1 equals 4n over 3n plus 1. And to give everything the same common denominator, you have to know what's in those denominators. So we're going to start out by factoring this first one, and I'm going to bet you that it turns into 2n minus 1 times 3n plus 1. Now if we check real quick, we get a 6n squared. 2n minus 3n is negative n, and negative 1. So if I was to give everything a least common denominator, it would actually be this. Okay, because this already has the 2n minus 1, it'd need the 3n plus 1, and this already has the 3n plus 1, it'd need the 2n minus 1. So when we multiply, we are going to multiply by, and I'm just going to write it on the right because I have no room on the left, but either side works. We're going to multiply it by both of those denominators, and we're going to distribute this to all three terms. So when you distribute it to the first term, notice that both are going to cancel, and you're just going to get negative 18 plus. When you distribute it to the second term, only the 2n minus 1 will cancel, so we're going to get 3n times 3n plus 1 equals, and when we distribute it to the third one, only the 3n plus 1 cancels, we get 4n times 2n minus 1. So from here, we're just going to do a little bit of distributing. 8n squared minus 4n, and then we're going to solve this. And so we do in this case have a quadratic, and so we want to make sure that we get those on the same side. Most of the time I do want my quadratic to have a positive leading coefficient, so we're going to move everything to the left. Rearrange, this is going to be n squared plus 7n minus 18 equals 0. And then if we factor, let's look at n plus 9, n minus 2. And so then my answers are negative 9 and positive 2. And just like before, you do want to check, are either of these going to give you an extraneous solution? So you're going to plug them in. And really, in this case, what would give you an extraneous solution would be a 1/2 right there. If you had put in a 1/2, that would give you a 0. And in this case, if you'd put in a negative 1/3, that would have given you a 0. So negative 9 and positive 2 are both okay. Alright, so our next adventure is going to be with radical equations. And so the main thing is that you want to undo the radical, and so to undo it, you're just going to do the exponent that undoes that radical. So we're going to look at number 56, and we're just going to start with 56a. And it says negative 3 equals the cube root of 5p plus 2. And so you cannot take anything out from under a radical. So you need to get rid of the radical. So to do that, we're going to cube the cube root, and those will cancel. And we're going to do this to both sides. And the one thing that you just need to make sure you remember is that whenever you do a power like this, or do a radical, like let's say I took the cube root of both sides, you do it to the entire side. You don't do it to the individual parts. And so keep that in mind, that this has to be done to the whole side. So this gives you negative 27 equals 5p plus 2, because the cube root just cancels. And then you're going to solve this for p here. So we subtract 2. Make sure I wrote it down right, just making sure. Okay, negative 29 equals 5p divided by 5, and p equals negative 29 fifths. And then what you're going to want to do here, you always check with radicals to see if there's something you can't have underneath it. Now, because this is a cube root, you can actually have anything under a cube root, so you're good. You might still check your answer, though. If I put in negative 29 fifths for p, the 5's cancel, I get negative 29 plus 2, which is negative 27, and the cube root of negative 27 is negative 3. So there's 56a. We're going to go to a new slide now. And let's look at 56b. And so this is 3 cube root of 3 minus 4x with a minus 7 outside equals negative 4. And so what I was just telling you about, you, in this case, cube whole sides, you don't ever want to cube that side, because you would have to take that binomial times itself 3 times, and you are going to give up before you're done. You can do it, but it's nothing that you want to do. And so in this case, you always want to get the radical completely by itself before you do that side to an exponent. So we're going to go ahead and add 7 to both sides. 3 times the cube root of 3 minus 4x equals 3. And then I would actually go ahead and divide by that 3. Make it as simple as possible for yourself. Alright, so once you get the cube root entirely by itself, now go and cube both sides. So we get 3 minus 4x equals 1. And then you're just solving for x. So negative 4x equals negative 2. X is going to equal 1/2. We're going to look at one more example on radicals. And, 56 does focus on cube roots, but keep in mind if you have a square root, then you're going to be squaring both sides. We're going to look at D. And that is 3 cube root of x plus 3 equals 2 cube root of 2x plus 17. And so what do I do when I have a cube root on both sides? Well, the good thing is that it's a cube root on both sides. And so the the 3 and the 2 out front, you can't get rid of. That means you're putting it on the other side and it's still there. And so what I want to do is I'm just going to go straight into this time cubing both sides. And we are going to be using the property that says if you have a product to an exponent, that exponent goes to everything in the product, meaning that the 3 is going to be cubed, so you get 27. The cube and the cube root cancels, so that's x plus 3. Then we get 8 times 2x plus 17. And again, we have this fairly basic linear equation that we're going to solve. 6081 is 16x, and 80, I should really bring my calculator in here. 80 and 56 is 136. And don't ask me where I got two equal signs from. Alright, so we're going to move everything to the same. X is on one side, constants on the other. So 11x equals, just going to subtract 81 and get 5 and 5. So we get 55, which means x is going to equal 5. And you should always check to make sure that that works. And again, for the case of cube roots, that will work. So if you had a square root, though, you cannot have a negative under square root. So if the answer you get for x gives you a negative under the square root, you just need to cross it out because it's an extraneous answer. Okay, so one last topic we need to talk about is, what if it doesn't really fit into one of these models? And so we're going to use Usubstitution, which we did talk about back in the review chapter. And we're going to start with number 66. So 66 is not a polynomial because it has a rational exponent. So that knocks it out of being a polynomial. And it doesn't really follow, we could write it with a radical in it, but it doesn't really follow our radical rules. And so what I want to do is see, does it exhibit the same behavior as a quadratic equation? And if you remember, we talked about that this variable squared is this variable. So in the case of x and x squared, it is. So in this case, I have x to the 3 halves. If I square that, what do I get? I get x cubed, because an exponent to an exponent, you're multiplying. So that has the same relationship as a quadratic. So if we use Usubstitution, and we're going to say u is x to the 3 halves, which makes u squared be x cubed, I can then rewrite this u squared minus 9u equals negative 8 and solve it just like it was a regular quadratic equation. So I'm going to add 8 to the other side. I'm going to factor this, minus 8 minus 1. And I'm going to get u equals 8 and u equals 1 by the time I set those equal to 0 and move that over. Okay, but what does u equal? Well, u equals x to the 3 halves. So x to the 3 halves equals 8, and x to the 3 halves equals 1. And so how do I get rid of the 3 halves? The best way is to take it to the 2/3 power. Because again, exponent to an exponent, you're going to be multiplying, and that's going to give you just x to the 1st power. We do it to both sides. This is the cube root of 8 squared, which is going to be 2 squared, which is 4. So we get 4 for one answer. And so you do the same thing here, 2/3, 2/3, and 1 to any power is just 1. And so there's your answers. So we're going to try the Usubstitution one more time with number 70. And 70 is d squared minus d, and that is squared, minus 8 times d squared minus d plus 12 equals 0. And so, if you wanted to distribute and combine like terms and such, you could. But if you look at this relationship, this variable squared is this variable. And that's where our Usubstitution comes from, that I'm going to make u equal d squared minus d, and I'm going to make u squared then equal d squared minus d squared. So if I rewrite that, it becomes u squared minus 8u plus 12 equals 0. And I'm going to factor this. And it's u minus 6, u minus 2. Okay? And then so I get u equals 6 and I get u equals 2. But then you have to go back, what does u equal? So I get d squared minus d equals 6 and d squared minus d equals 2. So now you were going to want to set those equal to 0 and see if this factors. So if we do minus 3 plus 2, that one factors, and so then I get d equals 3 and negative 2, and d squared minus d minus 2, so that's going to be d minus 2d plus 1, and so d equals a positive 2 and a negative 1, and you end up then with 4 answers, which is fine, because if I had figured this out to begin with, that would have been a d to the 4th. All right, so there's what I want to go over in 1-6. Again, if you have questions, please let me know, and have a great day.